Trigonometry, a sine rule exercise. An exercise based on the sine rule. If you're given a triangle ABC with length BC equal to A, length AC equal to B, and length AB equal to C, we have A over sine A equals B over sine B equals C over sine C, or sine A over A equals sine B over B equals sine C over C. Now we're given an exercise. In question 1 we're asked to find the missing side x in each of the triangles, and in question 2 we're asked to find a missing angle in each of the triangles. Pause the video at this point, have a go at these questions yourself, and when you've finished, start the video again and I'll go through the answers. So let's see how they're done. Now in question 1, part 1, we've got a triangle with one side 8.6 centimetres and two angles 63 degrees and 35 degrees, and we have to find the side x. Now the first thing to do is to label the diagram. Then, using the sine rule, which is A over sine A equals B over sine B equals C over sine C, we have angle A is 35 degrees, side B is 8.6 centimetres, and angle B is 63 degrees. Now the side A is labelled x. So, x over sine of 35 equals 8.6 over the sine of 63. If we multiply both sides of the equation by the sine of 35, we get x equals 8.6 times the sine of 35 all over the sine of 63. Now if we work that out on a calculator, it comes to 5.536163. So if we round it off to one decimal place, the side x is 5.5 centimetres long. If we look at the second triangle, we've got a side given as 6.9 centimetres and two angles, 130 degrees and 23 degrees. So if we label the sides of the triangle and then use the sine rule, A over sine A equals B over sine B equals C over sine C, we have the angle A is 130 degrees, B equals 6.9 centimetres and B equals 23 degrees. So substituting it in the formula, we have x over the sine of 130 equals 6.9 over the sine of 23. If we multiply both sides by the sine of 130, we get x is equal to 6.9 times the sine of 130 over the sine of 23. And working that out on a calculator, we get x is equal to 13.52773. which, when rounded off to one decimal place, x is equal to 13.5 centimetres. In part 3, we have a triangle with sides 9.4 centimetres and angles 42 degrees and 65 degrees. Now, to work out the length of side x, we need to know the angle opposite x. That's not given, but we know the angles in a triangle add up to 180, so the angle A is 180 minus 42 and 65, which is 180 minus 107, which is 73 degrees. So, using the sine rule, A over sine A equals B over sine B, we have the angle A is 73 degrees, the side B is 9.4 centimetres, and the angle B is 42 degrees. So, x over sine of 73 equals 9.4 over the sine of 42. If we multiply both sides by the sine of 73, that gives us x equals 9.4 times the sine of 73 all over the sine of 42, which from a calculator we get x is equal to 13.43424. So, rounding it off to one decimal place, we get x is equal to 13.4 centimetres. Now in part 4, we've got a triangle with one side 15.3 centimetres and two angles 22 degrees and 25 degrees. Unfortunately, to use the sine rule, we need to know the angle that's opposite the side, 15.3 centimeters. Now that's not given, but we know the angles in a triangle add up to 180, so that angle is 180 minus 22 minus 25, and that's 133 degrees. So we can then use the sine rule, A over sine A equals B over sine B. A is 25 degrees, the side B is 15.3 centimeters, and the angle B is 133 degrees. So substituting it in the formula, x over the sine of 25 is equal to 15.3 over the sine of 133 degrees. Multiplying both sides by sine of 25 degrees, we get x is equal to 15.3 times the sine of 25 over the sine of 133, which we can put in a calculator and get x is equal to 8.841221. Well, rounding it off, that gives us x equals 8.8 centimeters. Now in question 2, in each part, we're given a triangle with two sides given and one angle given, and we're asked to find a missing angle. So, in part 1, we're given a triangle with sides 7.8 and 6.8 centimeters and an angle of 50 degrees, and we're asked to find the angle theta. So we're going to use the sine rule, but this time in the form sine A over A equals sine B over B equals sine C over C. And we have the side A is 7.8 centimeters, the angle B is 50 degrees, and the side B is 6.8. So, substituting it in, we get the sine of theta over 7.8 equals the sine of 50 over 6.8. If we multiply both sides by 7.8, we get sine of theta equals 7.8 times sine 50 over 6.8. We can work out the right-hand side, that's 0.878698. So if we want theta, we need to take the inverse sine. And so theta is equal to 61.48571 degrees, or it can be 180 minus that. So theta could be 118.5143 degrees. Now, if we assume from the diagram that theta is an acute angle, we would have the answer theta equals 61.5 degrees. In part 2, we've got a triangle with sides 11.7 centimeters and 8.8 centimeters and an angle of 120 degrees. Now, the angle theta is not opposite one of the sides we know, so we'll have to start by working out the angle C. Using the sine rule, sine A over A equals sine B over B equals sine C over C. Now we have C is equal to 8.8 centimeters. The angle B is 120 degrees, and the side B is 11.7 centimeters. So, sine C over 8.8 equals sine of 120 over 11.7. Multiplying both sides by 8.8, we get sine C is equal to 8.8 times sine 120 degrees over 11.7. Working it out on a calculator, sine C is equal to 0.6513696. And to find C, we have to take the inverse sine of that. Now C comes out to be 40.64494 degrees. But it can be 180 minus that, so C could equal 139.3551. Now C can't be 139.4 degrees because there's already an angle of 120 degrees in the triangle. So C must be 40.6. The angles in a triangle add up to 180, so theta is 180 minus 120 minus 40.6. And our answer is theta is 19.4 degrees. In part 3, we have a triangle with sides 8.4 centimeters and 9.3 centimeters. It also has angles 72 degrees and theta. However, theta is not opposite one of the sides that we know, so we'll have to start by working out the angle A. So using the sine rule, sine A over A equals sine B over B equals sine C over C, we have the side A is 8.4, the angle B is 72 degrees, and the side B is 9.3. So sine A over 8.4 is the sine of 72 over 9.3. If we multiply both sides by 8.4, sine A is equal to 8.4 times the sine of 72 over 9.3, which works out to be 0.8590187. Now to work out A, we need to take the inverse sine of that, and so A turns out to be 59.20658 degrees, or 180 minus that, so A could be 120.7934 degrees. Well, we can see from the diagram that A is an acute angle, so A is equal to 59.2 degrees, in which case the angle theta is 180 minus the other two angles. So it's 180 minus 72 minus 59.2, which works out to be 48.8 degrees. So our answer is theta equals 48.8 degrees. Now in part 4 we have a triangle with sides 14.2 centimetres and 7.8 centimetres, an angle of 30 degrees, and we're trying to find the angle theta. So using the sine rule, sine A over A equals sine B over B equals sine C over C, we have A is equal to 14.2 centimetres, the angle B is 33 degrees, and the side B is 7.8 centimetres. So putting them in the formula, we have the sine of theta over 14.2 equals the sine of 33 over 7.8. Multiplying both sides by 14.2 gives the sine of theta is equal to 14.2 times sine 33 over 7.8. So the sine of theta works out to be 0.9915223. Then theta is equal to the inverse sine of that, and that works out to be 82.53407 degrees, or 97.46593 degrees. Now if we look at the diagram, it's a bit difficult to see which of those two answers is accurate, so the safest thing to do is give both answers. Theta could equal 82.5 degrees, or theta could equal 97.5 degrees.